Hello there, Gregory Carlson here for College Algebra. You might notice we're in our new office, so that's really exciting, but let's get to the math. We're on 2.5 part 2, and this next piece says we have a line through the point -6, 3, and a slope of 12 over 5. Write the equation in standard form. So you can see that we have a point and the slope. They've given us a point and the slope, so what formula should we use? That's right, we should use the point-slope formula because that's how you represent a line, knowing the slope and knowing a single point. So that formula, let me just write it down right here. I remember big Y minus little y is equal to m times big X minus little x. And we're just going to plug in these things, and they want it in standard form, so we'll have to remember that. So we're going to start by plugging in our point. Here's x and y. So, sorry, try to focus here. It's going to be y minus 3 is equal to our slope, 12 over 5, times x minus 6. So there's a few things to notice here. First of all, notice that, if my camera will focus, notice that the numbers we plug in are the second numbers in both of these cases. So the big Y and the big X we can't change, but we change the small y and the small x. Also notice I have two negatives because in the formula we're subtracting and I have to subtract a negative. So those two negatives will turn into positives. And next what we'll do is we'll go ahead and do the distributive property. And so that'll turn the formula into this. Nothing going on the left. On the right we're going to have 12 over 5x. And then 12 over 5 times 6, that's going to be 72 divided by 5. So there's our new formula, y minus 3 equals 12 over 5x plus 72 divided by 5. So we're getting this in standard form, so we need to move our x term over and add this 3 over. So let's add the 3 over next. So that'll give me y is equal to 12 over 5x plus 72 over 5 plus 3. And the next thing we should do is we should subtract 12 over 5x over. So we do minus 12 over 5x minus 12 over 5x, which means that we'll get y minus 12 over 5x, and that'll cancel it, is equal to 72 over 5 plus 3. So here we are. We're at y minus 12 over 5x equals 72 over 5 plus 3. And you might think we need to do some math to combine these fractions, but we want the problem in standard form. And in standard form, it's better to do it without fractions. So I'm going to multiply every term by a number to cancel these fractions. And since they're the same number, I just multiply the entire equation by 5. And remember, that means multiply every single term by 5. So we'll get 5y. These 5's cancel. So we get minus 12x is equal to, these 5's cancel, so we get 72 plus 5 times 3 is 15. So you can see that that made it a lot nicer. Again, we're doing this to get the formula in standard form. Now, standard form, they like to put x first. We can also combine these two terms. So the final answer is negative 12x. I'm just going to flip them. Plus 5y is equal to 72 plus 15, which is going to be 87. So there's the equation in standard form, and that's all there is to it. If it doesn't give you the correct answer for this, you might need to just multiply the equation by -1 to change all of the signs. So if you do that, that would give us 12x minus 5y equals -87. So it just depends on how strict your homework software is. So if this isn't working, try this one. So that's how to put an equation in standard form. Let's see how to put one in slope-intercept form. It says a line goes through 2, 5 and has a slope of -3. Write the equation in slope-intercept form. So what we're going to do is we're going to use this formula again so that we can, because we have a point on the slope. So it's going to be y minus the y value is equal to our slope times x minus the x value. That's how you put this information in point-slope form, and you do need to memorize how to do that. Next, unlike last time where we're going to move all the x and y over and get rid of any fractions, this time they wanted a slope-intercept form, so that simply means solve for y. So the first thing to do is the distributive property, y minus 5 equals negative 3x plus 6. And then we're actually just one step away. Just add 5 and add 5. So that gives me y is equal to negative 3x plus 11. And you can see that that's in mx plus b form, which is slope-intercept form. Next one, write the equation of a line going through negative 2, 5 and parallel to x plus 3y. This is an interesting problem because we don't know what the slope is. We simply know that the line is parallel to this line. So when they say just write the equation of a line, usually what they mean is write it in slope-intercept form. So first let's figure out the slope we need to have. And to do that, we need to convert this into slope-intercept form. That means solve for y. So we get 3y is equal to negative x plus 7. There you go, 3y equals, sorry my camera, I'll try to fix it before the next video. 3y equals negative x plus 7, divide by 3, divide by 3, divide by 3. So we get y is equal to negative x over 3 plus 7 over 3. So this equation right here is equivalent to this equation, x plus 3y equals 7. And so, but the main thing we need to know from this is the slope. So we look over here and we see from here that the slope is going to be negative a third. So that means that since we're parallel to this line, the slope we're going to need is negative a third because that's the slope of this line. So now we just use point slope with this point. So it's going to be y minus big Y minus little y equals our new slope times big X minus little x, which means x minus minus 2. So these two minuses become pluses. And then we do the distributive property with the negative a third. So y minus 5 equals negative 1/3 x. Negative a third times 2 is negative 2/3. And then finally, we're just going to add the 5 over. So that's going to cancel. And so we're going to get y is equal to negative 1/3 x. So what's negative 2/3 plus 5? The way I would do that is I would take 2/3 away from 5, which would give me 4 1/3. Another way you could do it is 5 is the same as 15 over 3, because you can multiply top and bottom by 5. So 15 over 3, take away 2 over 3 is going to be positive 13 over 3. So there's your answer. Y equals negative 1/3 x plus 13 over 3. And again, that 13 over 3 came from negative 2/3 plus 5. Let's try to do this last equation. Write the equation of a line going through this point and perpendicular to this one. So in the previous one, we were doing a parallel line. Now we know that we're perpendicular to the line 2x plus 4y equals 11. So again, we need to figure out the slope of this. So subtract 2x. We need to put it in y-intercept form to figure out the slope of this line. So we get 4y equals, I would put the x term first. So we get 4y equals negative 2x plus 11, and then divide by 4. So let's go ahead and reduce this. Negative 2/4 is the same as negative a half. Notice I'm leaving it as a fraction. And it's really important that I left it as a fraction because the slope, which is negative a half, we need to find a slope perpendicular to negative a half. And we know, hopefully, this is something you need to have memorized. If it's parallel, the slopes are just the same. If it's perpendicular, you find the opposite reciprocal, meaning change the sign and then flip the fraction. So negative a half, what's perpendicular to that is 2 over 1. So that's going to be our slope. So use point slope formula, y minus y is equal to our new slope, 2 over 1. Now if it's 2 over 1 like this, you can just leave it as 2, or you can put it as 2 over 1, it doesn't matter. So y minus y equals m times x minus x. And then we'll just put this into slope-intercept form. So those become pluses. Y plus 2 equals, do the distributive property, and then finally subtract 2. So the formula is y equals 2x minus 10. And you know you did this correctly. One way you can check your answer is by plugging in these 2 points to see if they'll go into the formula and make sure that both sides are equal to each other. But we've just come up with the line perpendicular to this one that goes through this point by using the point slope formula. So we have one more thing to talk about in 2.5, and I will see you. It's very important, and so I will see you in part 3.